this talk of the talk for lesson 4. Use the given rectangles to answer each question. First of all, calculate the perimeter of each rectangle. So in the first one, perimeter is adding up all of the sides. 6 plus 4, which is 10, but there is a 6 on that side and a 4 on that side. And so when you add them all up, the perimeter of rectangle M is 20. In the other triangle, rectangle N, we have a side length A, and it's not known. But because it's a rectangle, the other side is also side length A. Same reason that the other side of B is also side length of measure of B. Perimeter is what you get from adding them up, all the way up. And so I'm going to write it like this. Perimeter equals 2A plus B. Because there are 2 A's, 2 B's. So I'm going to add them up. Draw a square with the same perimeter as each rectangle. Okay, so if we have a square, and in that square, this 20, it's a rectangle because the 4 and the 6 on the sides are not the same amounts. But I bet if I drew the square like this, I'm going to freehand it. So I'm going to try to freehand it. So I'm drawing right angles, drawing the sides all the same. Pretty decent. If I did 20 divided by 4, 20 divided by 4 equals 5. So all of the sides of my square have a side length of 5. We can do the same thing with this perimeter to try to figure out how big the square is. So I can do 2 of A plus B. And if I divide by 4, I'm going to get the side length of all the sides. So 2 divided by 4 reduces to a half. And then the A plus B just continues to happen. This does work with the 4 and the 6, right? If A was 4 and B was 6, we'd have this example. So these two examples would be the same. They're not always, but right now, what if they were? Then it would be 4 plus 6, 10, times a half, 5, equals 5. So we would have proof that our questions line up, okay? Calculate the arithmetic mean of the values of the sides. I'm going to draw this rectangle, by the way, the square. Square, square, 1/2 A plus B. 1/2 A plus B. Okay, calculate the arithmetic mean of the values of the side lengths of each rectangle. Arithmetic mean is average. I would call you average, but that's just mean. The arithmetic mean is the average. Now think back to the last time you heard about averages. To find averages, you would add up and divide by the number of numbers. So I would add up 5 plus 5 plus 5 plus 5. Divide by 4 to get my answer. So 5 plus 5 plus 5 plus 5 is 20. 20 divided by 4 is 5. This sounds very redundant, and yet there's a purpose for it. It's setting up what we're going to do with this one. I'm going to take the perimeter, and I'm going to divide by 4. And so when I do that, these two values, these two measurements, are actually going to be the same calculation. So if I have a half of AB plus a half of A plus B plus a half of A plus B plus a half, these are all the sides all the way around, of A plus B. And then I divide that by 4 because there are 4 of them. I'm still going to wind up with, you guessed it, 1/2 A plus B. Then calculate the area of each rectangle. So this rectangle, the area formula is length times width. So in this rectangle, the area would be 4 times 6, which is 24. In this rectangle, the area would be 5 times 5, which is 25. In this rectangle, the area would be A times B. So we'll do these two rectangles up here. Area equals 6 times 4, 24. For the other one, the area is A times B. And there's no way to write that nicely. Maybe just don't write the dot that represents multiplication. We just take that dot out, and I'm just going to write AB. Which means the same thing, right? When we have multiplication with letters in mathematics, multiplication just pushes the two letters together. Okay, draw a square with the same area as each rectangle. So if we have a rectangle here with an area of 24, then the way to find the area, the square with the same area, is to square root the 24. Square root. Because square root 24 times square root 24 actually ends up canceling the square roots, and we have 24 left over. I mean, like this. Area would be root 24 times root 24, which is root 24 squared, which then translates to the square and the square root canceling out. They're opposite operations, and we get 24 left for an answer. The area here is also 24. Let's do that with the other rectangle. But in this one, it's going to be the square root of a times b. So here's our square. It has an area of AB. And then because of the relationship of area to side length, each side length is going to be square root AB. Square root AB, all the way around. It is a square. This is a square also. So then the area would be square root AB times square root AB. That's side times side. And it's going to equal the same as square root AB squared, which is canceling out. Squares and square roots reduce each other, and we're left with AB when we're done. What's the point of all that? Write a proportion and solve for the geometric mean of the values of the side lengths of each rectangle. So the geometric mean of this rectangle would be the number that is somewhere between the 4 and the 6, so that x over 4 equals 6 over x. That's what we mean by writing a proportion and solving for the geometric mean. So here it goes. X times x makes x squared. 6 times 4 makes 24. And to solve this, we have to do the opposite of squaring, which is square root. And we'll square root, both sides. So therefore, x equals square root 20. That answer is that side length of that square. Kind of weird. Oh, maybe that's what geometric mean is supposed to represent. It's the number that squaretizes, not a word, the side lengths of a square when we don't know the exact area. We know the exact area, but don't know the square's side lengths. Let's do that for this one. So we have, back on this rectangle, AB, but we do know the area of that rectangle. So we're going to do A over x equals x over b. The geometric mean, didn't show it. There we go. The geometric mean of this rectangle is written like this. Geometric mean for that rectangle AB, there we go. Okay, little cross multiply action, x squared equals AB. This is geometric mean squared is the area of a square that would be having the same area as our rectangle. Learn something new every day. Let's go. X equals square root AB. Geometric mean. In geometric mean, you're looking at the proportions where on one proportion, our unknown or our geometric mean is on the bottom and our geometric mean is on the top. And then together, they combine to create some like side of a square geometric mean. Thanks for watching this video. This has been lesson 4. It's been real. It's been fun. We got some more stuff coming up. Our next video will start on page 506. Thanks for watching. Like, comment, and subscribe. See you in the next episode.